Yes. Once again, a very good morning, good evening to all of you people. I'm myself Kumaran, and I'm based out of India, and I'm a full-time MLOps engineer and a data engineer into my cloud role, into my job role. So, getting started with the the agenda of this uh, program. This program focuses mainly on the very niche subject in the space of machine learning, where a lot of companies have been able to build their machine learning models, but are struggling to go ahead and build their ecosystem around the deployment part. So this is where we as MLOps engineers will be required to play a vital role in helping the organizations to go ahead and get their models developed and deployed. So I've been working in this space for the last 4 to 5 years now, and I have been garnering experience around this MLOps. So I'm going to go ahead and explain you what exactly is machine learning and MLOps part into it. So to get an understanding about it, let me go ahead and give you a simple example, and let me give you some meaningful insights about it. So let me take you to a very popular website called Kaggle. So Kaggle is a very popular website which is used by a lot of companies for their data science or data machine learning projects. So it's a company that is held under the name of or handled or taken care by Google itself. So what they offer some data sets. So let me give you some example data set for now. Okay, now let me go ahead and get you some data sets. So from the given data sets, let me go ahead and give you a very popular data set, for example, called California housing data set. So this is a very, how do you place it? It's a kind of a data set that is used by a lot of developers when they get started to do the machine learning model. So if you scroll down to this data set, you will see the data set comprises of following details. So what are the following details? Let me make it more visible for you. Yes. Now you see in this screen or on my screen now you see there are certain parameters that are given. There are about 10 parameters. That means where exactly the property is located. What is the property age? That means how long did this property was built ago. Number of rooms, population, people, income, and followed by one line that is mentioned about the property value. So if you want to get to see those values, you see here the values are mentioned here. So this is the latitude, longitude, and you get to see how old it is, the number of people, rooms, and the value of the property. What is the current value of the property? Now imagine we want to go ahead and have a machine learning model built that can do predictions based upon user giving all these details. That means user will go ahead and give where exactly it is located, what is the property, how old is the property, rooms, population, households, median income, and all this. So we want a model to do predictions. Participants, are you with me, everyone?
Yeah.
So what they are expecting to do some predictions. Prediction means for the new data, that means if it is located in somewhere in California, with regards to these number of rooms, maybe 3 bedroom to that of four, 3 bedroom near the ocean or near the water, followed by the number of people around. We want to do the prediction for the property about 10 years old. So they want that model to do predictions. So why predictions tomorrow? If a new customer or the consumer wants to go and buy that model or wants to go buy that house, he should get an average estimate of the property because there are a lot of other properties which are falling in the same range, their properties available. So I want my model to do predictions. Now they will hire a data scientist or a machine learning engineer. This machine learning engineer will go ahead and build models. So let me show you some models out of it. So how these models are built. So hope this is available in the form of models. Yeah. So this is an example model. So how a data scientist will go ahead and do the model development. So he will take that code, he will write that code, he will build that code. This is some Python code, so don't worry about it. You are not required to understand everything. But at a very high level, you see our data is loaded, model is being built. Then the built model is turned, you'll get to see the word model. So let me highlight about the model. EDA, feature engineering, and let me highlight about the very specific keyword called model. Yes, the word model evaluation. So model will evaluate that what is the prediction, what is the price for. So for this model will be developed by your data scientist. Data scientist will go and develop the model. So for this model which is developed, they are trying to test the data that what are the model that can you go ahead and give me the predictions for a property which is available. So now model is being evaluated. So here we are trying to go ahead and give inputs and ask the model to do. Now it is able to do predictions. So based upon the input that is given, it is able to do predictions. So what is the learning that we have done? We have been working with the data scientist who developed the model, and the model started to predict the price. So at line number 7, focus on line number 7. So model is developed and the model is expected to do predictions. It is doing predictions. Now company wants to make this available on their website so that people can go and use it. That means they go and give their inputs and model should go and do outcome. Now there is a need for them to go ahead and use a deployment engineer. A deployment engineer is required to go ahead and deploy that model. So that is where the new concept is picking up. That is through CI/CD model, we deploy that. And that's how the word MLOps came into picture. So let me go ahead and give a very high level overview of what the source code that I've been discussing and what is the target. So on my screen now, people, you'll get to see two circles interacting with each other or overlapping with each other, where you get to see one part of the portion where data was pulled, EDA, exploratory data analysis, data preparation, developing the model, and training the model. This is done by machine learning engineer. Is that very clear? Participants, is that very clear?
Yeah.
So as part of the model development, data was pulled, training is done, model development is done, model started to do prediction. If there are any changes, they will train it, retrain it. But the problem is where exactly this model is going to be available for people to use. So it should be made available for people to use. So it should be deployed somewhere. We need that model to get deployed somewhere so that people can use it, can refer to that model. Inference means people have to go ahead and connect to that model. People should be able to go ahead and reach out to that model. People should be able to go ahead and call out that model. People should be able to go ahead and talk to that model. So we need someone who can deploy. That is where the ops person comes into picture, the ops guy. So the ops person is the person or an individual who has a great responsibility. The MLOps person is an individual that will have a great responsibility to deploy that application. So I need to focus on deploying that application. So the moment the word deployment comes into picture, that what is your strategy? What exactly is the strategy to go ahead and deploy that application? So to deploy that application, we are dependent on the following strategies. So let me go ahead and talk about these strategies. So how we are expected to go ahead and build that model. So to make you understand, I have been writing the source code. Let me go ahead and give you the source code. So we will go ahead and build pipelines involving the deployment strategies using first is to Dockerize that application. So what we do, we go ahead and focus on Dockerizing that machine learning application. Can you see here a Docker code? Even if you don't understand, that's fine. But this is purely a Docker file. In this Docker file, what we do is we go ahead and build our environment. That means we will build a Python environment for our application. We get all the necessary libraries for us, our application to build. Let me show you the requirements.txt. So as a machine learning engineer, my machine learning engineer was required to go and consider NumPy, Panda, some Python libraries to make my machine learning model to work. So I have built it into my container environment. So this is my container environment. I'm running my application into it. I'm trying to go and bundle all the essentials in the form of installations. I'm trying to install them that are part of the installation. And what I'm trying to do, I'm trying to run my application. So what kind of application? Let me go and show you the application. So this is a kind of an application that I've been building. So this is a built application where I'm trying to go and do what? Predictions. I'm trying to go and do predictions with it. So I'm expecting the model to do predictions with it. So once the model is able to do predictions, I'm able to go and do the predicted value that this is what is the predicted value in the form of output. So where exactly I will deploy it? I'll deploy it into environment. What kind of environment? Cloud environments. We can consider cloud. We'll come to the cloud practice as well. But we focus deploying the Docker images into our Kubernetes environment. So we use Kubernetes for the purpose of deployment. So now connecting the dots. So developer is writing the code. We are trying to go and Dockerize it. The built Docker images, we are trying to go to deploy it. We are trying to deploy it. So participants, now you have understood what exactly the concept is all about. So there are two people. One machine learning engineer is trying to go and build the machine learning model on one side, right? And the other side, me as an MLOps engineer is trying to go ahead and focus on what? Building images out of it, the Docker images, and deploying those Docker images into Kubernetes environment. I'm trying to go and deploy my images into Kubernetes environment. Is this now a very clear strategy between the machine learning engineers and the ops engineers? Are we clear now?
Yeah.
So how many people are involved? At a very high level, there are two set of people involved. What are those? ML engineers who are writing the code for your machine learning, and the ops engineers who are responsible for deploying that code. So the very basic concept is deploy this code, and the machine learning engineers, they develop the code. So certainly the machine learning engineers, they develop the code, and the MLOps engineers, they deploy the code. So if we are focusing on the ops part, we will not go and spend time in the machine learning part. We will go and spend in the ops part. So for that, what we need? We need containerization in the form of Docker. We will go and use Kubernetes environment to go and run it. And once you build this entire skill, we are required to go and automate this process using CI/CD pipelines. And for that, you can also consider using cloud practices. So now companies have their environments running in cloud. So you need to find a way how to go and build these images in the form of Docker images and get those images built into cloud practices. For example, I want to now use cloud practice on AWS, and into AWS, if I want to go and run into AWS Cloud. So AWS Cloud offers a service called Kubernetes service called EKS. So you should know how to deploy it into Kubernetes environment involving EKS. If you use Azure, we will go and deploy the same thing into Kubernetes environment. So you should know what is Azure Kubernetes service. So whichever the cloud you use, you should know how to deploy it via the CI/CD methods into the Kubernetes environment. What you will deploy? You will deploy images. What images? Docker images. So what is that Docker image is all about? machine learning. So what is that machine learning? An application that is expected to do a kind of prediction that will take your inputs and that will give you outputs. Now, participants, is that very clear?
Yeah.
Now, it's been me that have been talking. So we'll do one thing. I'll start taking your questions and let me answer your questions accordingly. So Ranjit and Venkat, I hope you understood at a very high level overview of machine learning and the ops part. So can we take your questions, please?
Yeah, sure. So I have a couple of questions. So I think this is more like an offshoot of DevOps, right? So is there a prerequisite that we need to know DevOps?
Rightly said, Ranjit. I appreciate it. So when you want to go and build the CI/CD pipelines, it is built technically on the idea of DevOps only. Because if you see DevOps, the ops part is borrowed from the MLOps has borrowed the ops part from DevOps itself. So having an idea about DevOps, that will be a add-on for you, even if you don't have it. But as you more get into the building of the pipeline, very soon you'll understand the concept of DevOps. It's not something that is always required, but if you have, it will be an advantage. If not, it's okay. I'm gonna go ahead and give you some sessions where you will understand an idea about the CI/CD capabilities and how that CI/CD capabilities will work. About a session or two, then it should be easy for you to pick.
Okay.
But
Okay.
prerequisites at the kind of prerequisite, if you ask me thoroughly, I would suggest some basic knowledge of Python because you will work with a Python code and you need to write the Python code in such a way that your model can understand not the machine learning code, but on the part of the pipeline. So basic knowledge of Python shall be of great help.
Okay. Sure. So the next question I have is, I've also heard a new term called LLM ops. Is it same or different?
Okay. For me also, it's very new in the sense like I've heard it, but I haven't had any time of experience working in it. The reason
Okay.
is that these models like we are building are basically very generalistic models. So those models that we're talking about LLM are large languages model. So even for them, they need an ops part. See, everything, even for a simplest Hello World application to that of in a Spring Boot application or .NET application to that of a machine learning application, a Python code, everything needs ops to get deployed. So the moment the word ops comes into picture, so visualize the idea of the CI/CD capabilities being used to deploy it. So using these CI/CD capabilities, we can build pipelines, which are ops pipelines, which help us to go ahead and release anything. So you are talking about LLMs, then we can go ahead and take that LLM once again in the form of a image, in the form of a Docker image, and get it deployed into Kubernetes environment. So definitely, if it is LLM model, there should be some around a code, either in the form of a code or in the form of an image. So ultimately, you write anything, a piece of a source code, you will have to deploy that code. So if you deploy it, there is a deployment can be directly in the form of the code itself or in the form of an image. The word image comes in, Kubernetes comes into the picture. So in our case, since we are taking the code and turning that in the form of Docker images, so we will go and deploy it into Kubernetes environment. Hope that answers your question now.
Yeah. Yeah. Sure. One other question is, I know this is a new field, but how's the market and what's the rate we can expect in the US for this kind of a role?
Right. See, I don't have an idea exact about the rate, but I can go and talk about the market. So this is my experience. I come from purely DevOps background when I was working. So a lot of times I was not even aware that there was an MLOps. But what happened before COVID, a lot of the organization projects that we had were purely built on machine learning model. And they put good amount of time and good amount of resources in building the model. And 90% of the time in those projects were all machine learning engineers, they built great models. But one thing they were not able to go and do was to get these built models into production. They're not able to get that into production. That means almost a year they took to build a model, but they were struggling to get these models. And it took another year for them to figure out that how to get this. So there was an immense need for someone who can get this code turned into an image and get it deployed. And that's how I was being called that, can you help us from your DevOps principles, using your DevOps principles, the CI/CD capabilities to deploy this application? So even it was very much difficult for me during that time. So what I did a research about it, and I understood that it's great to go ahead and involve the build images or the build applications in the form of images using Docker. We are using Rancher also. Some of the projects we use Rancher for building our images. So what we have done trying to utilize the Docker and Rancher to build our images. Once those images were built, we were deploying into Kubernetes. And slowly, Kubernetes project got very much, uh, you know, uh, appreciation from a lot of the industry, and there was a need for them to also extend the support, especially for the applications, and that's how the new module for your MLOps came into picture involving Kubeflow. So Kubernetes is an open source for machine learning and MLOps. That means if you're targeting MLOps, you can use MLflow as well as Kubeflow. So Kubeflow has been big. Parallelly, a lot of companies are also utilizing MLflow for their machine learning model deployments using MLOps. So there is a need for a lot of companies either adapting to Qflow or MLflow to build their MLOps model. So based upon this, my suggestion is if there is a company which already uses Kubernetes for their application deployment, there's a very great chance you might see a scope for Kubeflow, Kubernetes modules, or if they're already using Databricks, Apache Spark, they will definitely use MLflow. So there is a good scope in both the spaces in machine learning model, the ops part, involving Kubernetes for Kubeflow and machine learning MLflow. So the market is getting very much accepted in both the spaces, MLflow and Kubeflow. And I would say it's really picking up.
Okay.
Okay.
And this is covered in your course?
Right. So we are using Kubeflow, our model deployment. So let me show you the Kubeflow modules that I'm using. So these are my Kubeflow deployments involving the Kubeflow pipeline development. So I'm writing the code for the Kubeflow module. So DSL component for the Kubeflow KFP, Kubeflow pipelines. So I'm using those modules. MLflow, we will very soon also be adding the MLflow. MLflow is one of my core expertise. I'm working on the MLflow as well. So I'm using MLflow as well for the purpose of learning in this training module. That means it's already part of a syllabus.
Okay. But in terms of the rate and everything, who will be able to guide us? Is Arjun, are you able to guide us or give some hint on where we are, current market?
Yeah, sure, Ranjit. Once after the training, we'll check the opportunities and we'll let you know the training how it is going. Okay.
Arjun,
If you
is there
want
any opportunities in
marketing
India?
from, sorry, Venkatesh.
Is there any opportunities for in India regarding this one? MLOps, any openings?
Exactly about India, Kumar, can you please let us know? Actually, I don't know the India market actually.
Welcome. See, the market of India
For
is
US
very,
market, Ranjit, sorry. Yeah,
yeah, welcome.
continue, Kumar.
See, the concept is very simple. A lot of companies, as I said, whether it is US and India, are struggling to hire people to get their models developed. Assume that the models are already developed. Now they need people to deploy that model. So a lot of companies, what they're trying to do is they're trying to use their in-house DevOps engineer to get their models deployed. But the problem with the DevOps engineers, they are very good in deploying it. They don't understand the concepts of Kubeflow. They are not aware of concepts of MLflow. So the people who come to our trainings, you will be very much surprised. Most of them are DevOps engineers. Why? Because in the companies, they have been asked to go ahead and upgrade their skill to Kubeflow and MLflow. So the idea is the people who are sitting in India, who are part of DevOps, are trying to go ahead and upskill themselves to the Kubeflow and MLflow. That means primarily there is a space that is available for people who are coming purely from DevOps background in-house, and also it is open for people like you who are coming from the outside also. That means if you come from the not you are not part of internal organization, but you're coming from the outside, you have a great scope to apply for other companies, and there is a need for the DevOps engineers who have good skills on the Kubeflow and MLflow. So India market is also open for it, and a lot of opportunities are trying to get open. But the priority, the companies at this moment, maybe they are giving priorities to the in-house employees, but it is also open for external employees like you.
Yeah, coming to US market, Ranjit, as per my knowledge, there is starting rate like 120K per year, per annum. Depends on experience and company, it will, there is a change, I think.
120 per year or 120 per hour?
No, 120K per annum.
Oh, okay.
Yeah.
In US, Arjun, right?
Yes. For Janaya also, same thing happening.
Are there any calls going on in US for this course, for this technical platform?
Calls means, what do you exactly?
See, I heard about that. For there are no calls for DevOps. They are looking for SRE engineers in US currently.
Okay.
Is there any chance for MLOps and AI with AI MLOps for us who has H1B?
Yeah, we'll look into it. We'll take care. If you want, I can provide you.
Yeah. Okay.
Ranjit, do you have any questions for myself?
No, that's it. I asked all the questions.
Yeah. Okay. Yeah. We'll discuss offline. No worries.
Okay, so thank you, Arjun and Ranjit and Pinkett. If you have any technical queries, you can compile and share it to Arjun, and I'll be very happy to respond to them. And firstly, we should appreciate Arjun for one aspect that he has been continuously making plans and suggestions that you people are waiting for a demonstration and to have a meet. And I really appreciate his efforts. He has continuously followed up with me to make this meeting happen. Thank you, Arjun. Thank you so much.
Thank you, Kumar. Thanks for your time. Yeah.
Welcome.
Thank you. Thanks for joining.
Thank you, participants.
Yeah.
Welcome.
Thank you, Ranjit.
Thank
Thank you.
Sure. Thank you. Thanks a lot, Kumar.
Thanks.
Yeah. Thank you.